Holding the 0.1 and dropping the 1.7.
It is literally.
Takes 0.6 seconds to drop.
Yep.
Holding 1.5 and dropping 0.2.
0.7.
Takes 0.7 seconds to drop.
The last one was 30. Yeah. Well, it lands on here too, so subtract a couple seconds.
Holding 1.5, dropping 0.475. Takes 0.5 seconds to drop.
No, that was very inaccurate, actually. There we go.
Takes 0.2 seconds to drop.
I'm not going to do that one again, because that's too loud. Here in physics, we enjoy loud noises. Hey, Brian, I think you're thinking.
These are my guys. This is not only from last semester. Brian, this is my guy. Brian and I are going to roll together.
Measurement is 24.
24 centimeters, Brian, so 0.24.
For the Atwood machine lab, question number 1, we assume that there is no friction, but how does friction affect the result in the real world? It slows the acceleration and resists motion. Question number 2, we assume the string has no mass, but how does the string affect the results in the real world? Creates more friction. Does the block have the same net force? No. Question number 4. Do the blocks have the same acceleration? Yes, at the same rate. Question number 5. As the difference in mass between two objects gets larger, how does that affect acceleration? Increases and approaches 9.8. Question number 6. As the difference in mass between the two objects gets larger, how does that affect net force? Still accelerating at less than 9.8. Question number 7. If you continue using larger masses, what is the largest the acceleration can become? 9.8, approaching. Question number 8. If you continue using large and larger masses, what is the largest the net force can become? Infinite. Question number 9. If the total mass of two different scenarios is the same, imagine if scenario 1 is 300 grams and a 200 gram for a total of 500 grams, and then scenario 2 is 400 grams and a 100 gram for a total of also 500 grams. Does the acceleration have to be the same? Explain. No, it does not. Question number 10. If the total mass of two different scenarios is the same, does the net force have to be the same? No, it does not. Question number 11. If the net force of the axle of two different scenarios are the same, do the masses have to be the same? Explain. Yes, they have to be the same. Question number 12. If you used a $10 block and a $5 block, then F net would be how much? 5. Question number 13. If you used a 20 block and a 15 block, the F net would be how much? 5. Would the acceleration in question 12 and 13 be the same? No, one block with more mass would have less acceleration. Question number 15. Notice the scenario 4 is twice as heavy as scenario 1. Is the acceleration twice as much? Should they be? Yes. The Atwood machine lab scenario number 1. Mass of object number 1, 300 grams. Weight, 2.94. Distance, it fell, 0.23. Time to fall, 0.35. Acceleration, 0.23 equals 0.045. Acceleration equals 5.11. Mass of object 2, 200 or 150 grams. Weight, 1.42. Net force, 2.94 minus 1.47 equals 1.47. Acceleration, 1.47 equals 0.3 plus 0.15 times acceleration. 1.47 equals 0.45. Acceleration equals 3.27. Scenario 2. Mass of object 0.15 kilograms. Weight 1.47. Distance 0.28. Time 0.65. Acceleration 0.28 equals 1/2 times acceleration times 0.36. Acceleration equals 1.56. Mass of object 2, 1 kilogram. Weight 0.98. Net force 0.49. Acceleration 1.47 minus 0.98 equals 0.9. 0.49. 0.49 equals 0.25 times acceleration. Acceleration equals 1.96. Scenario 3. Object 1, 500 grams. Weight 0.96. Distance 0.27. Time 0.7. Acceleration 0.27 equals 0.245. Acceleration equals 1.10. Object 2, 200 or 150 grams. Weight 1.17. Acceleration 1.96 minus 1.47 equals 0.49. 0.49 equals 0.2 plus 1.5. Acceleration equals 1.4. Scenario 4. Mass of object is 0.5 grams. Weight 4.9. Distance 0.24. Time 0.5. Acceleration 2.24 equals 1/2 times acceleration times 0.04. 0.24 equals 0.02 times acceleration. Acceleration equals 2. Object 2, 300 or 2 150 gram blocks. Weight 1.47. Net force 3.43. Acceleration 4.9 minus 1.47 equals 3.43. 3.43 equals 0.65 times acceleration. Acceleration equals 5.28. For the Atwood machine, we need a ring stand, clamp, pulley, string, and 2 masses. You take the clamp, then you take the pulley and put it into the clamp. You take the string.
Double-bladed shit. I have male, I have a crown tail, blue stripes, I got this full row of female. I have male, female,
Then you attach each of the weights onto one end of each of the strings.
I'm just trying to C, B, C, D, C sharp, A. Seriously the same?
And you have to take these smaller halves and drop them.
Yeah, I can't find.